Okay, this question says that in the diagram, OA, BC, D is a solid figure in which OA and OB equals 4 units. All right, so let's mark that. We have OA as 4, OB as 4, OD as 3, BC as 1. The base OAB is horizontal and angle AOB is 90 degree. Okay, so this is perpendicular. Vectors I, J, and K are parallel to OA, OB, and OD respectively. The midpoint of AB is M, and the point N on BC is such that CN equals 2 times NB. Okay, Cn equals 2 times Nb. We will be using that later. Express Md and On in terms of I, J, and K. All right. So we need to go from M to D. All right. So here's M and here's D. We're going to use this route. We can go from M to A, then A to O, and then O to D. That will give us MD. Let's see. So for part A, to find vector MD, we will be going from M to A, which we have to figure out, plus A to O, which is going to be negative 4i, and then O to D, which is plus 3k. Okay. How do we find MA? MA is half of BA, and B to A is minus 4j plus 4k. So BA is, we'll write half here, then BA would be minus 4j plus 4k. So I'm writing minus 4j plus 4i. So 4i minus 4j, which would be 2i minus 2j. So MD is now 2i minus 2j minus 4i plus 3k. So that would be minus 2i minus 2j plus 3k. That is MD. All right. Next is ON. So to go from O to N, from here to here, what we'll do is we can go from O to B and then B to N. Let's do that. So for ON, we're going to go from O to B, which is J, and then from B to N. Now we will have to use the ratio given, which was Cn equals 2 times Nb. That means if this has one part, then that has two parts. Cn is double of Nb. Okay, using that, that would mean Bn is 1/3 of, so instead of Bn, we're writing 1/3 of Bc. So J plus 1/3 of BC. All right. Now let's find BC. To go from B to C, we'll go from B to O, then O to D, then D to C. Okay. So we'll write J plus 1/3 of B to O is minus 4j, O to D is plus 3k, and D to C is going to be plus J. So this would be J plus 1/3 of negative 3J plus 3K. So that would be j minus j plus k. I have a very strong feeling something has gone wrong here. What was supposed to be the answer, or did I write an I in terms of j? Okay, so the answer should have been 3j plus k. So what did I miss? Let me just quickly give this another look. All right, I've noticed the big fat blunder, which was that to go from O to N, we first went in 4j direction. So instead of writing 4j, I just wrote 4. So I just wrote j. So this was 4j. So 4, 4, 4, 4. And then 4j minus j is 3j plus k. Okay, now the answer is correct. So ON is 3j plus k and first part is done. I should be writing arrows here equals ON. All right. Next part is part B. Calculate the angle in degrees between the direction of MD and ON. All right. We already have their direction. So we're going to find their dot product divided by the product of their magnitude. So cos theta equals MD is -2, -2, 3, dot ON is 0, 3, 1, divided by magnitude of each. So 2 square plus 2 square plus 3 square would be 17 times square root of 0 square plus 3 square plus 1 would be 10. Okay. Find the dot product of the numerator. That would be -2 times 0 plus -2 times 3 plus 1 3 times 3 times 1, which gives -3. So we have a -3 here upon square root of 17 and square root of 10 in the denominator. Now we find cos inverse of this fraction, which gives us 103.3 in degrees. Okay, that's part B. Part C, show that the length of perpendicular from M to ON is square root of 22 by 5. All right, for that, let me first draw the diagram for clarity. Okay, show that the length of perpendicular from M, so M is that, and we already have, do we have OM? Uh, mm, Okay, so we do not have the coordinate of M, so we need to find that out first. Anyway, M is here and ON is here. Let me draw that separately. So we have a line like this. So that's O, which is 0, 0, 0. And then N, which is, we also have ON, which was 0, 3, 1 from here. So 0, 3, 1. Okay. And we need to find the length of perpendicular from this M towards the line ON. All right, now first I need the coordinate of M. So for that, what I can do is I'll go from O to O to A, and then A to M. Let's do that. So to find OM, we're going to go 4I plus half of AB. And this was BA. We already know what BA is, or we can just calculate it from here. AB is -4I plus 4J. Okay. So OM simplified would be 4i minus 2i. So that's a 2i plus 2j plus 0k. So the coordinates of M are then 2, comma 2, comma 0. Acha, so we have the coordinate of OM or the position vector of OM. Now I need the vector equation MON. So the vector equation ON would be R equals, we need a coordinate, we can use OOO plus lambda, and the coordinate N031 minus the first coordinate 0, 0, 0. So the vector equation passing through ON is simply lambda 0, 3, 1. Okay, so that means if this is the foot of the perpendicular, then the position vector of this foot of perpendicular is going to be same as this because x lies on the vector line ON. So it will have the same equation, which would be 0, 3 lambda, and just lambda. That would be OX. All right. Now the dot product of OX and the direction vector of the line ON, which is this, the dot product of these two must be equals to 0 because they're perpendicular to each other. So OX dot the direction of the line passing through ON, which is this 0, 3, 1, will be equals to 0. So 0, 3 lambda and lambda dot 0, 3, 1 equals 0, which gives us 9 lambda plus lambda is equals to 0. So 0 plus 9 lambda plus lambda equals to 0. So that gives us, nice, something has gone off. Wait a second. I had to, oh, that's such a big blunder. OX, I had to find XM. What am I doing? Okay, so OX is this, but I have had to find MX. I don't know why did I overlook that. I had to find MX first and then find the dot product of MX and the direction 0, 3, 1. Okay, excuse my big fat blunder, please. So MX would be OX minus OM. OX is 0, 3 lambda and lambda minus OM is this 2, 2, and 0. So MX comes out to be minus 2, 3 lambda minus 2, and lambda. That is MX. Okay, now the dot product between MX and the direction of this line 0, 3, 1 would be equals to 0. So minus 2, 3 lambda minus 2, and lambda dot product with this equals 0. So we get 0 plus 9 lambda minus 6 plus lambda is equals to 0. We're getting 10 lambda equals 6. We're getting lambda is equals to 3 by 5. Okay. And we had to find the length of perpendicular. Show that the length of perpendicular from M to ON is equals to this. All right. So that means we need to find length of this OX. And we already have the expression for OX, which is this. So now replace the lambda with 3 by 5 and then find its magnitude. Sorry, no, MX. MX is not OX. MX is here. This is MX. So replace this lambda by 3 by 5 and get the proper column vector and then find its magnitude. So we get a -2 and a -1 by 5 after substituting the value of lambda and 3 by 5. Now we find its magnitude, which will be square root of 2 squared plus 1 by 5 squared plus 3 by 5 squared. So enter the squares and their sum in the calculator and we'll get 22/5. So this is what we had to show.